Welcome to EmberConf Day 1, or as I like to call it, JordanConf, with both Jessica and I on the docket. Fun story. I told Jessica today I claimed her as a cousin, and then she said, I think of you more as an uncle. So I don't know what that's saying about my age there. But so today I'm going to talk to you all about developing an Ember test strategy. First, a little about myself. I have been doing enterprise-y software stuff since turn of the century. I started out with IBM for a decade in Java, I know. And then I've been jumping around doing front-end development work, mostly in JavaScript. I think Initech was one of those companies. Currently, I'm working at Q2 Banking. We do online banking software for credit unions and small banks, similar to someone earlier, which was cool. If you bank with a credit union or small bank, you could be using us, and the way to tell is if it's an awesome experience, I will claim it, but otherwise it's somebody else. Also, I'm part of the Triangle of North Carolina development community. That's Raleigh, Durham, and Chapel Hill. This is Sir Tomster Raleigh. We are rebooting that meetup, so if you are from the area or moving to the area, hit me up. I would love to talk to you. Also, I've been on the learning team a couple years. We're really focused on coming alongside you, helping you out, making you successful with Ember, and there's a lot of work there. In my, humble and unbiased opinion, we're the coolest core team, so if you want to help out, we would love to have you. So, Ember loves tests. So when you install your first Ember project, you get first-class testing out of the box. You get Testem to run your tests continuously as you're developing. It can even segment your tests and run in multi-threaded environments. You get testing crafted around the Ember framework, especially. You have rendering tests. You have application tests that let you interact through the browser. You also have a whole slew of add-ons that enhance your testing experience, whether it be letting you use Mocha or letting you use page objects, HTTP mocking, and much more. But this isn't a talk about technologies. So this is, you've defeated Bowser, you've opened up hidden levels, you've understand Ember test, you have your test cases going, but how do you ensure your tests don't become a burden over time? As your project scales and becomes big, how do you keep your tests from overwhelming you and become more of a hassle to maintain than they're causing good? And so that's what I want to talk to you a little bit about today. But at the same time, since I'm a turn-of-the-century programmer, I wanted to mix in some origin stories about some of these concepts because it's great to understand the past as we get propelled into the future. So when you start a software project, it's likely to be something with a high amount of complexity and variables. So how do you go about producing a great quality project in a timely manner? So we're going to talk about speed and feedback loops. So the guy on the right here is Dr. W. Edwards Deming. He did a lot of cool things in his life. He was an expert in statistics and engineering, management, quality control. He spent a lot of time in post-World War II Japan helping manufacturing companies get back on their feet. And one of the things he's most known for is this thing called the Deming Circle. And essentially, it's applying scientific method to engineering and manufacturing problems. So you plan something, you execute, you analyze the results, and based on what you find out, you make adjustments. And you just keep doing this in tight loops until you've solved your problem. So one company that listened up was a small company called Toyota. They created this set of philosophies called Toyota Production Systems, and it was highly successful and influential on manufacturing. They produced at the time, and probably still do, some of the highest quality automobiles out there. And one of the major components of their philosophy was continuous improvement, and it took into account this tight feedback loops and continuously adapting based on what you learn to produce something of the highest quality. And this came back into software when Mary and Tom Poppendieck wrote this book called Implementing Lean Software Development, and they studied the Toyota production system and applied it back into software development. And this was pretty revolutionary. When you hear about lean software development, this is where that came from. Oops. Another smart guy, Dr. Barry Boehm, did some research on cost in software development. And what he found is the later that you find a missed requirement or a bug, the more expensive it is. And not only is it more expensive, it's astronomically more expensive as you get into production. So I don't know if anybody's shipped product to customers, but if you've shipped a bug into production, you've been on phone calls with really high-paying people very interested in you getting that problem fixed. And in your head, you might be seeing those dollar signs saying they're paying these people a lot of money to just be looking over my shoulder at this point. And so it's also true for further back in the software development. If you introduce a bug where a third-party tester has to find that bug, he has to spend the day describing that bug back to you so you can fix it and then verifying it. So you're taking up the salaries of both of these people. You're spending that time in the project that you could be spending adding business value. So in general, you want your feedback loops to be tight when it comes to testing. You want to adapt and learn as you go. And the earlier you find and fix your bugs, the more successful your project's going to be. So you do want to immediately regret your decisions. So the concept of feedback loop plays a foundational role in the types of tests that we choose. So let's take another trip down memory lane, I guess, for me. So in the 90s, the late 90s, Kent Beck and Ward Cunningham, some other developers with a background in Smalltalk, were doing some work for the auto industry in Detroit. They created this software methodology that looked very different than what was the standard at the time. It consisted of a variety of crazy practices like writing tests before you code and programming with a pair on one computer, checking in your code every single day and keeping your code working at all times. And it became wildly successful. And so in addition to these extreme programmers, they weren't alone. There were other people identifying that the way software was being done wasn't working. It was development first, and then once you've done actually design first, and once the whole design was done, then you did development, and then once all that was done, you did testing. And a bunch of these developers got together in 2001 and come up with a set of high-level principles describing how they felt software should really be done, and this was the Agile Manifesto. Now, this was a major shift in terms of testing from the way things were done. So instead of testing being done after everything was done, a lot of it got shifted up into these tight iterations that developers were using to enhance their programming. And so this is a visualization by Brian Merrick. He was one of the original signers of the Agile Manifesto to describe testing in an Agile environment. And as you can see on the left and right, it separates out testing that's done to support your programmers versus testing that's already done on a complete project to critique it. And today we're going to focus more on supporting our programming because I've got like 20 minutes left. The second part is super important too. That's maybe part 2, or if anybody else wants to take it on. There's also a great book called Agile Testing by Lisa Crispin and Janet Gregory that kind of goes through each of these quadrants and just describes a test in an Agile environment and how you would do them. So recommend that. So another contributor to Agile, a guy named Mike Cohn, he's one of the co-creators of Scrum, had this book, Succeeding with Agile, and in it he uses this visualization, and it's an idea of how to distribute your tests. So his concept was when you test through the UI and you test end-to-end, it's slow. And when it breaks, it's not always easy to tell where in the stack it broke. Now, it's still useful because it's testing out collaborations between the different parts of your project, but you shouldn't focus a lot of tests up there. You should only test up there where it's needed. You should more do the majority of your tests at that bottom unit level because they're fast and they should be easy to hook up and run and debug as well. And then there's a middle layer which he said if you cut out the UI and test against your API, and in most of our cases it's like a web service API, then you'll reduce some of the cost. It'll still be a little bit slower than unit tests, but you can still like hammer those APIs and get some benefit out of it. So if we take this back to Ember testing, the 3 types of tests that Ember provides are unit tests, which are the fastest. They call directly into the code, the object that you're trying to test. You have Ember rendering tests, which are still very fast, but they incorporate the template compiler and the rendering engine to give you a good holistic test of a component in isolation. And then you finally have application tests, which are actually booting up the entire Ember environment and interacting with it through a browser like a user would. And often you can mock this or stub the HTTP layer, which a lot of people do, but you can also use those to test end to end, but those are obviously the slowest. So if we take an average test time and write 1,000 tests with each of these, your application test is like a lunch break, right? It's going to be 33 minutes to run 1,000 tests. And so you might as well go off and go to your favorite restaurant and come back. Your rendering tests are a little bit better. They're more like a coffee break. And then finally, your unit tests is doing something quick, maybe like checking your Twitter notifications as long as you don't go into a black hole there. So let's distribute these tests a little bit. So if you just distribute them evenly, 1/3 apiece, you're still going to get kind of a short lunch out of that, right? You're getting 15 minutes. But if you do the right 2, where you are doing 40-40-20 or 40-50-10, you're getting into the range where you want to be. Plus, if you take advantage of Testim's segmenting and multi-threading behavior, you can cut these even further down. So if I had to reimagine that test pyramid, when you're running Ember, you want to focus your unit and your rendering tests and do as many of those as you possibly can. Then your service and your application tests with mocks are going to be in that middle layer, and you're testing the things that test good. For instance, an application test with mocks might be testing transitions between 2 pages and that the information is passing right, things that you can't narrow down with a unit test. And then finally, you have your end-to-end tests, which you still want to keep small. And like I said, you can still run those with application tests, or you can use a third party. So pro tips around this is you really want to push scenarios as far down the test pyramid as you can, as they'll be valid with, right? So if you have that route test, right, it may stop at the application level, but if you have a test that tests like a validation and if that logic is right, you can push that down all the way down to a unit test. Also, you want to avoid duplication between test types. So if you're testing these form validations with an application test, it might be doing the same thing you're doing already with the unit test. So you need to keep track of that, because you don't want your test suite to explode as your project scales. Now, if you have a very small project, it might make sense, but a lot of projects that I've seen and been on, it's really become a problem as your tests get big. Finally, this might be a little more controversial, but maybe delete tests that aren't sparking joy with you, to continue with the Marie Kondo reference. So I think sometimes we're afraid to touch tests once they're out there, but if a test is long running and it's not giving you benefit, sometimes tests help you out when you're developing something but aren't great in regression. So think about that and don't be afraid. So I'm going to talk a little bit about test workflow, and yeah, I'm going to go there. I'm going to talk TDD a little bit, but I'm not going to beat you over the head with it. So there's some interesting parts of TDD and philosophies behind it that might be good to know, even if you don't ever become like that TDD person. So I'll start out with another walk through history here. So this is a computer lab in the 70s. A couple of fun things to notice. Where the heck are the monitors? Also, I don't think there's any internet there or networking. So how in the world did you do anything back then? Well, they used these things called cards or tape. And essentially, this is a Fortran line of code. And they literally were punching holes that represent bytes in your program. And so when you coded something, you print these out and shove this into another computer. You'd also get output tape, too. And so when Kent Beck, one of those original extreme programmers, started doing TDD, he was inspired by an old programming book that said, well, you should manually punch holes in the tape that you expect your program output to be. And so when you code and run it through the computer, you can actually compare. And so he took that and he's like, well, we can do this with software, right? We can write a failing test for a small thing, make it pass, then do some refactoring on it to prepare us for the next set of tests we're running, and then repeat it. And when you visualize this, it looks a lot like something we already saw, right? This is like the Deming Circle, right? So we're trying stuff out, we're analyzing what it does, and we're trying to keep these small, tight loops. So what a lot of people say with test-driven development is, isn't this going to slow me way down? I mean, I've said it. You may have said it. And so there's this guy named G. Paul Hill, and he was one of the original type of extreme programmer types and big TDD advocate, and he talks about this lump of code fallacy. And so I've done this. So when you're estimating out code, you're like, I can crank this out. Just type it out, and it'll be done in a couple days. But actually, when you're coding, you're doing a little bit of typing. You're waiting on dependency management. You're reading code, trying to understand, what you're working with here. You're Googling stuff because I've forgotten, I forget half of computer science after a month. You're chatting, posting dank memes on Discord or whatever your team chat is. And you're constantly running stuff, right? And you need to keep running stuff to make sure it still works after you add new stuff, like the stuff you did before doesn't break. And then finally, nothing that I do ever works the first time, so you're doing quite a bit of debugging there as well. And so the concept was that if you add automated tests and you add them early, at the same time, at least, while you're coding, then you're going to reduce some of these tasks. Like your debugging will go down a little bit. You're running stuff. You're not having to do it manually. You're using Testum to continually run your tests while you're coding. Then it should even out. In fact, it might even be better in some cases. So let's visualize the steps we talked about. You write a test, you write the code that passes that test, and then the refactor step is you try to refactor things so that you have reuse, you don't end up with large bloated classes. And this refactor step is pretty important because it's kind of what forms your object tree. So if you just TDD against an API surface all day long, you're going to have one giant object without any refactoring. You're really kind of creating the collaborators as you go in your refactor step. And let's take this to Ember. So one place, I think classic TDD works out pretty well in one place in Ember and a couple places in Ember, but the one I'm going to talk about is right here. So if you think about a page in Ember, like a route template, and you can create a component that represents that page, and you can start from there and think about the inputs and the outputs that page is going to have. And so in this case, it's like a profile page where you enter in your first name, your last name, email, and a profile picture, right? And those are going to be your inputs. And another input might be an action that you pass that you want it to tell you when they click the submit button so you can go ahead and save that information eventually. So if we use the same visualization to talk about that, you start coding your profile page component, right, with those inputs and outputs. And then in your refactor step, first you get the test to pass, but then you've got a profile page component, and it has all that stuff in it. But then you find that the upload picture task is taking up a lot of code, and it just doesn't quite seem right in there, right? And so then you refactor out a new component for that, right? And so as you go, your template kind of forms itself as you go through these steps. So when you do kind of this classic TDD, sometimes it lends itself, and one way to do it is it lends itself to a kind of an inside-out programming model. And let me show you this on kind of on a macro level. So a lot of times they'll say, start with your core logic. So if you're developing a mortgage calculator, you want to make just a Pojo good mortgage calculator API and test the mess out of that. And use stubs when you need to, but you want to avoid using stubs. And then once you have that core logic there, you can strap on an API layer. Say I want to represent this mortgage calculator with a web service, and then you drive that with tests, and you drive the web service API. The web service API already has the core logic there to test back into. And then you can go out another layer further, and then with end-to-end tests, you can drive your UI, and then you have a full working system. So in the early 2000s, a slightly different way of TDD came about and got popular with the extreme programming community in London. And it made use of mock objects as a way. And there's later on a book called Growing Object-Oriented Software Guided by Tests was written. Super book. I recommend it, even if you don't use kind of this mockist view of TDD. And so it made use of mocks. And what I mean by that is when I talk about stubs, it means just a class stand-in that always returns a certain value. But mocks add a little different layer to that, and it allows you to actually assert the behavior of your collaborators. And so when you do test-driven development, you can actually define and assert what your object is going to interact with the world with, and you can use this as a form of need-driven development. So as you go, you're kind of creating the next layer of API, and you kind of work yourself through the system. And so in Ember, I think one popular mock object library is Sign-On. I'm sure there may be others. And so let's visualize this in action. So you have a failing test. You start writing the code for your test, and then you start thinking about, well, what are my collaborators, and what potential APIs is this object going to work with? And then you create mocks that interact with that, which then gets your tests working. So the mocks are your roles, so you're essentially deciding what the roles are, and we'll get to that in a second. Your mocks become the APIs for your next test. So you've got a working test here, so your next test is going to be against those blue things. It's going to be the API created by those, and you keep working back until you hit a boundary, or what they call a leaf, which means there's no other dependencies, and you can just use classic TDD on it. So let's take this to Ember. One place where I've seen kind of a mock view of TDD work pretty well is in services. So I've been on a couple of complex projects, and the service layers have gotten a little bit crazy, okay? And so here's an example of a chat service providing information to a chat. I'm chatting with the Discord help bot. So what this chat service is going to do is going to fetch some chat history. It's going to incorporate some profile data with that. It's going to receive incoming messages and send outgoing messages. So if we represented this, we start writing a test, and then we start implementing our chat service. And then we think about, well, what's this chat service need to do? Well, it needs to interact with like a real-time service so we can subscribe and get chat messages in. It's got to interact with the profile services so we can get information about the person we're chatting with, display a profile picture, display his name, and other information about him. We can also connect to a history service to load all the previous chats before this instance we have going on. And so, the test works when we add the mocks, and then we have direction for our next set of tests. We're going to write tests against each of these services that we've created mocks for. And so as you can see, it becomes kind of a need-driven development. So with this kind of development, it lends itself a little bit more to outside in workflow. So you could write a failing end-to-end test and then start driving tests through the UI, which then creates mocks which describe your API. Then you can drive your API that you've discovered through tests and mock out the core logic, and then drive your core logic backed by mocks as your data. And then once you have that, you have your end-to-end tests working. And I'm not implying here that you write your UI before you even start on your backend. You do this in small slices, feature by feature, as you go about your project, so then you always have a full stack working thing going for you. So, which should I do? Heck, either, neither, both. It really depends on what you're trying to do. Understanding these techniques are like tools in your tool belt, right? So I encourage you guys to study up on this stuff and to just figure out what's right for you and try different things. So one of the co-authors of that book, Growing Object-Oriented Software, said it best, I think, where he said, these are just tools, right? And there's no golden hammer. You just need to understand how things work in the context of TDD and use the right thing for your situation. So some parting perspectives from a turn-of-the-century programmer. You might hear all this at a high level and are like, holy crap, you know, I'm not into doing all this, and this might not work for me, or whatever seems a little bit overwhelming. So a blog post sticks with me. And so this guy named Michael Feathers wrote a great book back in the day called Working with Legacy Code. And it's how to do TDD against a big mammoth legacy code, which I felt like this has been my life. So he was speaking to my soul. So what he was doing in this blog post though was comparing mock TDD. And he comes from more, you know, he was an old extreme programmer as well, and he was, you know, comparing the new mock TDD, and he was like, well, there's some flaws to this. I didn't think it should work, but then I worked with some teams that were doing it, and it was working really well for them, and their code was amazing. Right, and then it made him think about some other methodologies used in the past. So there was Clean Room, which you know, did some extraordinary amount of examination to each commit. And there's Design by Contract, which pushed a whole lot of ceremony around your APIs. And you know, all these techniques did one thing: is they were successful when done right, and they drove down bugs. Right. And so his reflection on that was that, you know, quality is a function of thought and reflection. And any discipline that you can incorporate into your daily life that increases thought and reflection is going to help you out. So if I had to leave you with anything, or in summary, I guess you could say, keep an eye on your feedback loops. Consider testing, even when you're early, because your project's going to grow most likely in a lot of cases, and so it can get out of control quick. So if you're making careful decisions of what tests you're doing and how fast your tests are running, then it's going to help you maintain this thing in the long run. Be methodical in your tests, and test in a way that drives your design, even if you're not, you know, a purist TDD person. You know, write your tests in a way that are methodical and gives you discipline. Finally, thought and discipline are going to be faster in the long run than just cranking out code. And that's all I have. Thank you so much, and hit me up on social media if you have any questions. Thank you.